Okay. So
Okay, sir.
binary tree is something binary tree is, as the name suggests, right? Binary tree is what it is. It will be uh two. Binary means two, right? 0 or 1. So it's actually two node tree. It's a two node tree. Binary tree means it's binary, as name says, right? It's 0 or 1. So it will be having at max two children. For every tree node is called, every point like this one, right? Let's say a Sabha. So this is called a node in the binary tree term. Like linked list, we call a node, right? Similarly, we call this one, each and every element in binary tree, we call like a node. It will be having at most two children in the binary tree, 0, 1, or any other ways you can think. Or it can have only one as well. Just 1 second. Like this, actually, we having all the trees. So it can have, like in this case, actually, let's see. Instead, let's store some numbers. Let's say this is 15. This is 20. This is 10. This is 5. So if you notice, actually, there is logic here, actually. How I organize this one, there is a small logic. So every time, right, and if a node is created, if the value is less than that value, it goes on to the left. If the value is greater than that value, the parent, it goes to the right. So a parent left is or a branch, actually. A left is a lower value, right is a greater value. So the main purpose of this approach is to have a sorted order. Even in the tree set, coming back to our collections, so we have linked array list, where actually we have a fixed size, but dynamically it can grow, and every element can be accessed through an index. That's what a collection, one of the collection that 1 second. Just 1 second. Yeah, I'm back. Sorry about that. So I'm coming back. Like array list is actually to store a collection of elements, but that is a fixed size. It can dynamically grow, but each and element are accessed through an index. Storing an element, reading an element, everything is through an index. That's what the purpose of array list. Next, we learned about linked list. Linked list, it's of any size. Storing an element is actually tedious if you are adding a if you are adding an element at the end of the list, but the rest of things like modifying the list, deleting the element from the list is easy in the linked list. So if you have more reads and more frequent updates, best more reads and just adds at the end of the list, then better to use the array list. And we learned about yesterday we learned about hash set, where it avoids duplicate elements. So similarly, it's not ended there itself. Sometimes we may need actually a sorted order. Every element we may need to every a collection need to be sorted when we uh, create a collection. So that's where we actually Java introduced a concept called Treeset. All the elements in Treeset is in sorted order. So let's first actually look at that how it works, whether it is working in the sorted order or not, and then we will see like how it really working. We'll go into deep dive into that. So as I said, like Treeset, it's a Java class, sorry, Java API class. We are using it. It is the same implementation of set interface. So it has the same like yesterday's has set, right? Whatever the methods it has the same methods and same convention how you can initialize and add the elements. So if I want, I can get yesterday's student just to explain it. I'm first commenting all equals methods. So I have same student class, name and student. Now, same thing actually, I am iterating all the elements. I first added alpha, beta, right? First I will add S2 and S1. Let's see like how it works. Okay. So I just added, instead of adding alpha first, I added beta, and let's see like how it works. See, as soon as I added, it's showing that cannot be casted to comparable interface. Cannot be casted to comparable. Unlike set actually, it's not it's not the list actually. If you are implementing any custom objects, you need to implement a comparable interface. That we'll see that what it is. But what let me see like adding a plain data, not the object. Let me see like adding the plain data. First beta, alpha. So this is string. Okay, let's see like how it works. See, though I have added beta first and then alpha next, see what it is printing? It's printing uh, in the alphabetical order, right? So set dot add, let's say I will add gamma. Still it is printing in the alphabetical order. So first actually I am adding zeta. So still it is printing in the alphabetical order. You can notice that actually why it is coming G is in lowercase, right? That's why actually it is coming in the next sequence. So if I add set add alpha in lowercase, it will be treated as a next number. See, alpha, beta, gamma, alpha, gamma. So everything is actually coming in an alphabetical sequence. Though whatever the, irrespective of whatever the order I'm adding, it's coming in the alphabetical order. So same thing actually, if I change my implementation to as set, if I change my implementation to asset, it actually prints, it avoids duplicates. There is no duplicate here, but it prints the way actually how I have added. It prints in actually it's not printing in the way it is. It prints in the random order. How it is stored internally. That's where actually it prints that one. So every time you will see this format. So if you add any new elements again, so we never know actually what's the sequence of this delta, where it will come. It prints in the random order. But we may need sometimes actually to have everything in a right order. That's where actually we'll go with the tree set. But how does tree set know it actually? In what order you need to sort it? So if you look at the string, it's string, right? If you look at the string API, if you look at string API, any of this one, it actually implements comparable. Along with string, look at this the declaration, public class string, and implements serializable and comparable as well. We are more focused on this comparable. Yesterday also I sometime back actually I was explaining the comparable here. Comparable comparator. So what's the difference between that? We will know that. In order to, this is your natural orders, right? This is actually element string. This is actually your numbers. So you know like what is the sorted order easily. Okay. In case of strings, in case of custom objects, you need to implement what is the sorted order. Like maybe sorted order is different according to one needs. Numbers, okay, it's a sorted order, like it goes in the sequence order, so on. So when it comes to our custom objects, we need to supply what is the sorted order. So in order to implement Treeset, we should always implement a comparable interface to our object. So this is my object, right? So we should always implement comparable. What it will be there in the comparable interface, right? So look into this one, comparable interface. It just have only one method, compare to method. In order to combine two objects, right? In order to insert in the binary tree, like what order actually it has to insert, that's where actually it should know it. So in this case, right? So what happens? Let's go. I'm adding alpha. So alpha is here. So how does actually beta know that actually it's greater than alpha? Or same thing, gamma is less than or greater than alpha. How does it know it? We need to supply it. So what data it need to supply? We need to compare actually. When we compare with alpha, whether it is giving a greater value or not. So it works like this, right? Like let's take this time names. Now I want to add one more element, Shahid. So where can I add it? This element? How can I add it? So I will go on first check with the main branch, Madhuri. So M, for me the sorted order is alphabetical sorted order. Right? So for me, M and S, if I compare both, S is greater. So I will come here. Right? So next I want to add, next I want to see like whether it goes, this element will go to the left of Saba or right of Shaba. So let's say if now what I can think, okay, second letter, S and S is same. Second letter, A and H. A is obviously the first one. H is the next element, next to A. So the sorted order will be for me this one. It goes right to Saba. So next one, maybe I want to add one more element called Rocky. I want to add Rocky. So then what I will do? Okay, I will go and check with same thing, same process, always same process actually, how we can add the element. First, we will check with Madhuri. It's greater than, so we'll go here. Here, if I compare S and R is less than S. So it goes in the left. Now you guys tell me where it goes, this element. Where does this go?
Next to Kavya.
Right of Asha.
Asha.
Right. So it goes right of Asha. So how it is? It compares Madhuri, it's less element. Kavya is still less, so it has to go left. And when it come to here, right? It's not right of alpha, it's left of
Left.
left of Asha.
Left of.
So it goes here. So that's the comparable logic. For me to store these elements in a sorted order, that's what my comparable logic. So every time, so it has to come to a appropriate position. I need to compare with everything. So my comparable logic, again, it's a binary tree, right? My comparable logic, it only returns two, uh, uh, one of two actually. Is it greater than or is it less than? Or is it equal? If it is equal, actually it can place in anywhere, like either left or right in a balancing tree. So if it is same coming as or right. But one more thing, we are not adding it, it's a set, right? We are not adding a duplicate element, so it won't get added. So that's where actually it will forbid that one. So now actually, let's say one more element. Lakshmi. So where this goes? So it's obviously less than this one. So in order to do this one, right, what we need every time, we need, is it greater? Is it less? Is it equal? One of these three statements should be good. So what it will do, it will go that now my method, right? There is a method called compare to method. Compare to method. Here it should actually check with the two objects and give one of this as a return type. Compare to method, it should check with given any two objects and it should give one of these two methods. So let's say now actually I am comparing first, in order to pass, in order to add Lakshmi, what I need to do, if I do, or let's say set dot add Lakshmi, if I do, right, what it will do, it first takes to the head or root, okay, then it's compared with the Madhuri, Lakshmi. So it should, this method should give one of these three. Is it equal? Is it less? Is it greater? So how it works is, okay, now Madhuri is less than Lakshmi, LM, right? It's L and M. Okay, so Lakshmi is less than Madhuri. So what it will do? It will give, it is less. So how it will denote? But actually here the return type is int. So what we will do in a programmatically, we will assign values for each and every one. So greater than, we may denote it as 1. Okay. Less than, we may denote it as -1. Okay. Equals, we'll treat as 0. So if it is -1 value, right, that means it's less than, it goes to left side. Now actually it came here, right? From Madhuri, it came to the left node. Now it tried to compare with the Kavya. So what should it give here when it compares to Kavya?
It is greater than Kavya.
Right. So it should give like a one as a return type. So then what it will do, it will go and place in the right side. Because it's empty, no need to further navigate it. It goes and place it here. Likewise, actually, we will implement the compare to method in our logic. Okay. And then sort all the elements. So let's go back to our example. Before we step on to that, is it any questions on this one? What
No,
is
sir.
compared
No,
to?
sir.
No.
Okay. Okay. What is compared to everything is good, right? Okay. Now let's go. Comparable. We always need to implement comparable, because that is the only element, only type that is allowed to add into the tree set. Okay. When we, this is actually interface. Again, going back to the interface, when we implement any interface, we should always override the unimplemented methods. So here the unimplemented method is this one, compared to. So we need to override that. So it's end of the method. So what I'm doing, or you can use the editor itself actually to implement the override, implement methods. It will override, it will ask you like what methods you need to override. Yeah. So it needs to return. So this is object. First thing is let's cast it as the object to student. I just casted it. Now next one is I need to compare this one. So we have actually two elements, name and class. So my first priority I will do is if class, if this dot class is greater than student dot class, then return one. So what I'm doing is it right? It's reverse order, I think. My logic is actually here. If student so higher class students, I want to print first and then lower class students. If student classes are same, then name comes. So what I will do here, coming to the name, in the string class, if I look into string, this is my string API. It's already implemented the comparable interface. Look this one. So instead of I am writing it again, I will give it to string, and they already implemented the compare to method. Yeah. So they already implemented the compare to method. So instead of I implementing for the string, I will give the rest, I will reuse whatever there in the string implementation. So what I will do, I will here, the next one, right? I will consider student dot name and then compare to student dot, sorry, this dot name. So I also need to write a logic for less than as well, less than and equals. So return, first I consider the class, what class they are in. If they are greater than, return 1. If they are less than, return -1. Okay. If they are same, then go with the student name ordering. So let's see now, adding the elements here. I'll remove this one. Okay. And now I will add these elements to my set. Now it shouldn't throw any error. So set dot add S1. See, it's not throwing any error. Earlier, actually, it is asking, because there is no comparable interface, comparable implementation. It was asking to it. It is throwing the compile time error that okay, this is not implemented. Now my custom object is already implemented with the comparable. It shouldn't complain about that. Okay. Now all 4 elements I have added. I am running the program. It's here. See what it came. Actually, it's my logic is reverse, I think. That's why it should be this dot name student. So here also dot class student, this student. Yeah, now it's coming in the right alphabetical sequence, right? So if I add a new student with a different class, alpha again, okay, but he is in 11th class. See, he will come first and the rest of people next. One, two, three. Oh, I didn't add him. Still wrong, right? It's the higher class students should come first. So that's right, actually. I did again confuse. This is still right. Here, this is right. Yeah. So higher class people comes first, and then the lower, the alphabetical sequence actually will do. 'Cause this is how actually it will add to the set. Again, we can run it. So no matter what, actually, what are the elements we are added. So let's say now I want to add another element with a duplicate. Bravo 10. Yesterday example, there is a hash code and then equals method, right? I haven't implemented, I commented that code. Okay. Now I'm just adding Bravo to my list. Okay. just adding Bravo to my list. Let's see if that gets added. It didn't add. Total size is 5. It didn't add second time. 1, 2, 3, 4, 5. It didn't add second time Bravo. So it still works the way actually how you want to the set, right? It's a still set. It still avoids adding a duplicate element. Java internally considered this as a duplicate element. Okay, because all the same element are there. So if you want to have your own custom implementation of checking like what is duplicate, you can always go and implement hash code methods. It is advised to have your own hash code method. Okay. And then equals method than giving the responsibility to Java. It is always advisable whenever actually you do a data class. Generally, we call this one as a data class. Whenever you implement a data class, it always advisable for you to implement hash code and equals methods according to your business needs. If you don't have anything else, right, still you can call super.hashcode to pass the hash code values. Or if you still feel pain, right, it's simply, instead of you taking that responsibility, your editor can also help you. Just right click, okay, click generate. Okay, here actually override. See here, equals and hash code. That is specifically designed for this purpose only, equals and hash code. Then it asks you like what template you want to use it. Is it Java 7 template, some other IntelliJ default? Everybody comes up with their own algorithm or their own way of implementation. Also ask you if you need to consider this one with the subclasses. No, right? We don't have any subclasses, so I'm not checking it. So I can go with any of the templates that is there. Next. Then it asks you like what fields you want to be part of the hash code and equals method. Suppose you want to just take name, you just uncheck the fields. If you want to take this one, then choose all the fields or the required fields for you. Next. Next. Non-null fields. String cannot be non-null. So you can check that. See how beautifully it is implemented. It all checks with a null fields and everything. Then it adds that one. Same with equals. Right. So this is the way actually it can implement the logic without you taking the responsibility. It creates that one. So what it is doing here, it checks first actually if reference is same, then true. Meaning reference is same means every object will be having its own reference. So let's look by debugging that one. See here you notice references 710, 711, 712, 713. It's actually a memory reference where it is object reference in your RAM, a reference address actually where it is located. For Bravo and Bravo, right? If you notice, though it is same data, it's still created like a different reference. So for example, if I am adding, I already added S2, I'm adding S1, right? So in this case, right, what it will be like, memory reference will be same. I'm still adding 2 times this one, right? So it avoids actually, though I'm adding a repeatedly a new element, just a second. Okay. So though I am repeatedly adding a new element, okay, it avoids adding S2. It just keeps adding that script S2. Just run this one and see if it is adding second time S2 element. S2 is what? My Bravo. It didn't add. It has to add 3 times, right? If it is a list, but it is not adding the same element. So that's what actually first thing is, it just the reference is same. No, if reference is not same, then it goes, if it's actually not required, if class is same. Are we adding class? It's not required actually for our example. So I can take it out. Now student. This is also not required. It's also checking the class only. So then what it is happening? It's only checking on the name portion. Name dot equal student name. Then it's again, if you look into this one, they are also actually utilizing the equals method of string, not re-implementing it. They are utilizing the equals method. So they are passing. If name is same, then they are passing. Same thing for hash code. They are only checking 2 fields here. Class. First, actually, they are getting name hash code. They are from the string class. And then they are doing some algorithm here. You don't need to worry about that one. But they are also using your class to define that one. So if you want to see like what it is printing every time, you can see it. This is what actually it is printing every time you run it. Okay, it's actually going to here only. It's not coming to hash code method at all. When it comes to hash code method, alpha. Am I had it a little bit? I'm in the right class. Okay, I'm in right class. So alpha 0. So alpha 0, Bravo, beta, Bravo, 0. So if it is 0, okay. So what is happening here is, if results is 0 here, it's not going to call any hash code method or equals method, because it treats here only like a the equals. It satisfies here only as a duplicate element, so it will not go further to add the element. That's where the tree set logic is. In tree set, these will not play much role. Hash code and these will not play much code, uh, much results. But actually, maybe you can use this one, right? What generally we do, right? We still use the hash code instead of checking like this. Okay. Let's comment out all this code. Okay. We can check with hash code value only. If this dot hash code equals to o dot hash code 0. So else, or we can use like a if greater than result equals to 1. If this dot hash code less than o dot, then result equals to -1. If still they are same, then we can go with equals. If this dot equals o, then result equals to 0. So you can check based on this combination. You can still leverage the hash code values, but actually the hash code, this is what actually in programming in a project we will do implement. We still leverage hash code values rather than checking each and everything. Uh, we'll lean on the hash code value. So okay, now let's see what it runs. It came differently now. It all the methods actually it's called. So what it added? It added alpha, beta, alpha, alpha, bravo, but it's not in the sorted order, right? So we can tweak actually if why it's coming like a sorted order. Why it's not coming sorted order? Because of it's the hash code value. So hash code value here. One second. Hash code values. This one is my logic, right? If this dot hash code equals, I'm comparing with so I'm comparing now. This is nothing actually. it does not have any results here. So it passes here. Now my set has already result. This is Bravo. So Bravo has to be greater than, yeah, right. Okay. It's still going to equals method. Okay. Result is 1. So it's coming to the top. So if I see the result, alpha Bravo. S3. So now S3 will compare with alpha and Bravo. So student is this one. This is what I am adding. Beta I am adding. Okay. So beta will compare with alpha and Bravo. Beta will compare with alpha and Bravo. So when it compare with alpha, the beta value is showing less than. Yeah, so it is less than. Well, so this beta hash code is beta hash code is 2066960. Okay. But alpha hash code is yeah. So alpha beta is considering, for some reason actually in this case, based on the hash code value, it's considering it's less value. So it's going to the less. Likewise, actually you can implement our own logic as well. So for some reason, actually, some of the elements based on our equals and everything, they considered as alpha is there, beta is there, Bravo is there, Alma is there. Yeah, only 4 elements are there. So only 4 elements are added here. But the sequence actually is something coming different because we are leaning on the hash code value. So if you don't want hash code, as I mentioned, you can still use the compare to method, name.compare to, without using this one. Simply use this one so that actually all the elements will be added to this. Yeah. Alpha, Alma, Alpha, Beta, Bravo. This is my sorted order. Okay. So this is all about Treeset, how it will sort the elements when it is added during the add itself. So any questions on this one, Treeset? Any questions from anyone? Did you guys follow it?
Sure.
Okay. Now let me add a poll. So you guys answer me. How much is?
Hello.
Yeah. Yes.
సార్ హ్యాష్ కోడ్ మీ ఈక్వల్ యాడ్ చేయకుండా ఒకసారి మళ్ళీ చెప్పరా
Okay.
కన్ఫ్యూజింగ్
Okay. So, okay. for Treeset, right? Okay, for set, right? What is yesterday I told that in order to identify an element if it is same or not, we need hash code and equals method. So if equals, first actually it will check on the hash code. If the hash code value is same, then it will go and check for the equals method. That's what yesterday we learned about. But today, right, we are checking the equality by using a compare to method. In compare to, actually, you can write any logic that can compare two elements. Whether you can use hash code or whether you use equals, it up to you actually what you can do it. But it can only give a one of these three things. If it is equal, it will not add any more actually. If this value is equal, right, the element will not be added. That is what this. If it is greater than, it goes to right side. It goes to the right side of the tree. Greater than value, we can denote anything. Like I can give like a 10, right? Any value I can give. Less than will go to the left side. Less than value also I can give 1. So it Java knows actually only natural number ordering. So based on these numbers, actually, whatever you are returning, that's where actually it is int. Okay, this is int, right? Based on this number, Java will sort actually where I have to place a new object. Let's say actually I am getting another new object called Lila. Okay, so where this object has to go, it will be determined by compare to method in this tree set. So in the compare to method, you can write like your own logic where these conditions where this can result in one of these three. Okay, so now actually, let's say you are writing compare to with a hash code. If this dot hash code is greater than new object dot hash code. So what if this means what? This means this object, right? This object you are checking with this one, this one, this one, everything actually, whatever the argument it is coming here equals, right? This means you are presently being added. Whatever you are adding here, right? If you are adding beta, that means that will become this. The rest of elements, whatever there in the object reference, actually, whatever already previously added, those will come into as a argument. So now, right here, this is this one. Maybe let's say this hash code is giving something random value, this one. Now this value is have the hash code value, this one, and this value is coming some value like this. So it will go and check with everything in this case. If you implemented the hash code, so 90234 and 902, this one, right? It's obviously greater than. It will come here, and it will add in one of the field. Like okay, let's say Sabah has hash code. Okay, same thing. Rocky has hash code. Shahid has hash code. This one, right? So now Sabah, you will check again. This object will check with this one. Is it greater than? Yes, by looking at the numbers, it is greater than. So it will go to right, not to the left. It will go to the right. So Shahid, still it is right, right? So it will go and add this one. That is with hash code method. But that is not what my business today, right? My business is I want to sort based on the alphabetical order. So what I will do, I will actually implement my I will not implement, I don't need to implement the hash code or equals method. I can simply still achieve my goal by simply implementing on the name dot compare to. So name dot compare to here, Lila is LM, right? So it's less than. So it goes here, Kavya, KIJKL. So KL, right? It goes here. And it goes here. It goes right to Lakshmi. That's what I changed my code later again. I just demonstrated like what hash code purpose, how you can use it here. But again, I changed my code just back to comparing with the name only. Okay. Some questions. Yeah. Yeah, Madhuri. So it's yesterday, right? Maybe you can go through the video once more time. I haven't posted actually. I will post it today. You can go through it. If any questions, actually, you can come back and ask me on that.
Okay, sir.
Okay. So this is what about Treeset. Any other questions here? So again, why Treeset we use? Treeset maintains sorted order. Right. First thing is it maintains sorted order. So how will it will maintain sorted order?
In ascending order.
Sir, what's up, Dharani?
No, sir. I am asking in ascending order only trees can do, or in descending order also.
It's up to you, like how you want to do it. So let's say here, Treeset example, you want to sort them in the descending order, right?
Yes.
So what you can do, this compared to, you can negate it. I'm negating it, right, with just minus sign. So which means actually I'm reversing the order. See now actually it's reverse. Right? Bravo comes first, which supposed to be last. Bravo comes first, beta comes, it's a descending order for you according to you. So if a new element zeta is there, let's say this is zeta. So he will come first. Okay. Did you follow, Dharani?
Okay, sir. But in recent we can also use pole first, pole last.
Sir, what's that? Can you repeat?
Pole first, pole last. We can use it in Treeset.
Yeah, for set for last, I didn't get it. You what would it? I didn't get like what those two words are.
Like pole first, pole last. There are lots of function in Treesets.
Okay. Yeah. We can use that one. Yes.
Okay.
It has actually many things.
Yeah.
Set here actually comparator, C floor head. Floor will give the first object. Headset, right? These are all many things. Last, what is the last element? Pole first. Every time it gives you the first pole last. These are the things actually where there are many things according to your need. Actually, its simple thing is you can simply go to Java API. What it is, many times even I do that one. Like Java is like a vast subject. You can't actually go and explain each and everything, but simply actually you can go here whenever is need, right? You can go and see like what is pole first, pole last, what it is doing. So it's not here in the pole first. So tree set, right? So what pole first? Retrieves and removes the first layer. That's what it will do. Poll first, it will retrieve and removes the one, and also it returns the first element. So what it's saying is, so if we do poll first, first actually it's printing this one, right? Just as a, I want to see all the elements are added. I want to show you like a, what after adding. So you can say that student first equals to set dot poll first. So what it does, it actually gives you a student object. What it is coming after doing the poll. Let's see after doing the poll, like how my list is. It will remove the first element, right? That's what they said. So you can see it. Sorry. See, zeta is removed, right? First zeta was there here. Zeta was here. Zeta is removed. Next one is all four elements are there. So same thing actually if we do with poll last, it will remove the last element. Last element came and last element is not there here. It was there here in Alamo. Alama was there. Alama is removed and then it's not there in anymore. So according to business needs, actually you can use it. But these are actually rarely used methods. Uh, that's I can say it. Mostly we'll use the add functionality and read functionality because that's where your business logic will be most of the time. But it's good idea to learn everything. It's good idea at least to whenever you are implementing that first time, go and check Java API. What methods are there and how you can tailor your business and how you can utilize according to your business needs.
I'm having one more
Okay.
question.
Yes.
So like linked list will go back and front. What
Yeah.
about binary search here? What about Treeset? It will go back and front, or it will go in uh, reverse order, or it will go forward order also?
You mean to say no? This is only forward order. Okay. There is no backward order.
No, that is not.
Tree has only two nodes here. Unlike in linked list, actually we have like a previous and next doubly linked list, right? It has only one element, only two elements, left, right.
Okay.
Okay, now Treeset maintains sorted order. All objects that are being added to Treeset must implement comparable interface. Okay, that's the next one. So anything else we are missing? Yeah. So Treeset maintains sorted order. All objects that are being added to Treeset must implement comparable interface. Based on the compared to result, it will sort either ascending or descending. Okay. If compared to method is 0, then it will not add to the set. So that's all about Treeset. Any questions on this one?
No, sir.
Okay. Now, let's see. Can we continue for our next half an hour, or you want to stop here? I know it's holiday, that's why I'm asking.
From me, so
Okay, it's okay. Let me go and explain map now. Map example. So map is something where you want to store a key value pair. So for example, you might like a your phone number list. Okay. How you will store a name and then followed by phone number, right? So why you will do that one? Why you can't just store the numbers? Can anybody answer? Why you can't just store the numbers?
Because we don't know who is calling.
But number is there, right?
Yeah, we can't remember the numbers, right, sir?
Correct. So you can't remember the numbers. So actually you will store in a tabular form, right? Or ultimately it's going to be a table form, right? Whatever the way actually you store it. So what you will do, you will store in a tabular form columns. So here it will be like a name. Here it is phone number. So let's say Kavya has some number. Okay. Hari has some number. Okay. Likewise, actually, you can store all the numbers. Uh, when when you want to dial Kavya, you don't need to remember or you don't need to search like a what is. Even though if you remember, right, you can't, you don't need to access entire list. You can directly go to Kavya. You can type Kavya so that actually the number will follow whatever the number, right? It will follow and it will you can make a call based on that number. So what it is actually, it's a key. Name is nothing but a key. What you remember easily, and phone number is the value. Generally, most of the time, actually, you won't remember value, right? That's why actually you would store against the name. How many of you remember the phone numbers rather than by names? Anybody?
No.
no, sir.
Yeah. So it's always good to have like a key value pair. So coming back to our previous cases, in order to store this kind of data, the list is not good, the set is not good, then what would be my next approach? That's where actually your map comes. map always stores the data in key value pair. Map again has the different implementation like a hash map, key tree map. But today we'll learn about hash map. Map has a subclass called a hash map. So it is similar to your hash set, how it is implementing. So it uses the same hash map, hash reference to store that one. So how it will use all these keys are okay here as it is hash map, right? This keys portion implements a hash set. What does that hash set mean? It will not store duplicate values, right? No duplicate values. What it is? No duplicates. So hash set has no duplicates. Whatever the keys actually what let's say actually we're storing Kavya one more time. What it will do? It will override. It will go. Let's say we're storing some other value here. What it will do? This row will be uh, this row will be override with the next entry because it's the same value. Okay, so that's one of the disadvantage, like our advantage. Hash map also cannot store duplicate values. Again, hash map is an implementation of hash set where keys are stored in a hash set format and then it will store a reference. So how it works is, so you know hash set, right? So we have actually a hash. Every time we have a table, we have hash, right? One minute. Okay, so we have hash value, right? So hash value will come here. Let's say it is some hash value and then followed by the actual value, and this will be referencing to a value again. So that's where actually it will form the hash table. So if again, if there is any duplicates, it will form a linked list and then it will go. So the right representation is so first actually it is having a hash value and here it is a key, and key will be having first is hash value, key will be having a value again. So if key is hash value has same thing, again it forms a linked list. Okay, still it's not So hash value, right? If we want to store Kavya, so hash value it will first calculate. This is hash value. So key will be Kavya, and this will reference to a value. So Kavya phone number is nothing but actually, let's say this, this is her phone number. So this value, this will reference a value portion again. It's another form where it will hold, right? If hash value is same, right, then again it will form a linked list. So let's say if hash value is same, next key will be let's say Kavya1. This may be referencing another value like this. If hash value is not same, right, it will go and create another bucket. We call like a bucket or something. Maybe it's the release. Right? This may be pointing to another value here. Likewise, actually it will form, it will internally store that value. But what you mainly need to focus is hash values, hash set. Your keys are in a hash set. All are non-duplicatable values. If it is duplicate, it will override the value. It will still add, unlike set, right? Set won't add, right? Unlike set, here it will still add, but it will override the value. So what it overrides the value, if Kavya is coming again, right? It's this reference, right, will be wiped out. Only this reference will be there. The new value reference will be there. Okay, that's how actually it will form the linked list. Sorry, hash map. So let's look into one practical example. Then we'll know about more on that one. In order to add a map, right? So simple thing like hash map, we are starting with hash map. Okay, map equals to new hash map. We need to add, we need to create a object first, map dot. Unlike add, right here, we have method called put. Okay, so whoever there, right? Let me see who are there in the participants. A phone number. Let's say I can store any data, right? So this is her phone number. 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 Likewise, actually, you can add as many number of elements you want. So now, in order to read the elements, right? It's simply you can get, how you can get the phone numbers, right? So you can use get. This will give you appropriate value. So let's say I want to get phone number of Dharani. So this will give me Dharani phone number. So let's say string phone number equals to map.get. So we are storing that as a object. That's actually showing that. See, you will get the value of 3, 4, 5, 6, whatever. You get Dharani phone number. So that's how actually we'll store the data. But if you want, if you store any duplicate values here, if you store any duplicate values, so earlier it is 3, 4, 5, 6, right? Here, initial value. Now, overriding the value. So what it will do? It will, when you call this one, unlike set actually, and in set actually, it will not add this value, right? But here in hash map, what it do? It will not add into the new key, but it will change the value. So let's look into this. See, it changes the value. So overrides are possible in map, unlike set. And all map is to store the key value pair. So every object you want, right? You can store any object can come as a key. It's not need to be a string. Value also can be any object. You can store any value as a key, any value as an object. So while storing keys, it's important to implement hash code and equals method because it uses the hashing technique to avoid duplicates. Okay. Third thing is, if there is any duplicate element, it overrides the value. Now, in order to, if you want to read all the values, no matter what, you can still use for each loop, or every entry here is there. We can take it as an entry. That's where actually we call it a entry set. Read all entries. So read all entries. So how we will read all entries? Map dot, there is a method called entry set. See, it gives set. It's though it is map, though it is a table or map, right? It gives you entry set. So entry set, you can take set equals to entry set. Okay. This is set implementation. Now you can iterate from here all the values for each entry, and this is set. Entry is also there in the static class. We need to cast it, or we can simply generate here actually. So now you can print both keys and values. System.out.println. Key is what? Entry dot get key. That's what your key is. Value is, you can get value, entry dot get value. So likewise, actually you can iterate all the map elements as well. See how it came in. So every time you, again, order is not guaranteed here because it's a hashing technique, it will use it. How it will store, it's based on the hashing value. You can't control the first come first serve. Okay, any questions so far how we are adding into map?
No, sir.
Okay. I think we can stop here. Just go over this one, the map also before coming to the class tomorrow. We'll again revisit the same logic. We'll see like how it works. And there is a concept called tree map. And then also we sorted map. We'll visit all of them. And most probably we'll try to close collections tomorrow. Okay, again, I'm not going, I'm deep diving. as required. I'm not going touching each and everything. Nobody can do that actually. Even here, right? If you want to cover each and every method, it will take 10 years to cover Java. So I'm only touching what is required, and the rest of things actually it's like a spoon feeding for you. You can look at Java API and take it out. Okay. I'm stopping my screen share here. Also, I will stop recording.